Well, I think it looks so ridiculous and impossible. And you can tell it's real because it looks so fake, honestly. We'd have way better CGI if it was fake. But we didn't really test any of those materials for, because it's space hardened or whatever, So it just has the same seats that like a normal car has. It's just literally a normal car in space. It's just literally a normal car in space.
Credit to Harry Growler for this video. And Harry Growler points out something in this video that we've pointed out many times about spacesuits. And of course, we've gotten the rebuttal back on the spacesuits of, 5 or 6 psi is really not that big of a deal. Heck, my bicycle tires have 40 or 50 pounds of air in them, yada, yada, yada. But there's something that people are really failing to realize about vacuums and the measurements of difference between psi and torr, right? I listened several weeks ago, or several months ago, I guess at this point, to an industrial vacuum expert that was on Mark Sargent's show, and he starts talking about vacuums, and obviously they have incredible power to lift stuff, and they're not talking about when they put these vacuums on that they're talking tens of thousands of psi or torr of pressure or anything like that, but the secret behind vacuums is the closer you get to zero, when you get down to 5 psi, 4, 3, 2, 1, and when you go below 1, then all of a sudden it doesn't seem like it's a linear scale anymore. It seems like it's more of an exponential type of scale. And so here's one of the problems that we pointed out, talking about the spacesuits and also about the tires on Elon Musk's Tesla Roadster. When you put something that's already inflated or even has almost no air in it whatsoever, as this balloon does, virtually no air whatsoever, and you subject it to a vacuum, and mind you, this vacuum is nowhere near what is going on out in space, it will inflate and essentially blow up. Do you see any problems with the tires on Elon Musk's car? Absolutely not. The same thing would be happening with the spacesuits as well. And for you trolls out there that come back with the ridiculous argument of 14 psi isn't that much, or 6 psi isn't that much. That's not the point. The point is when you get below 1 psi and you go into the torr measurements, that's when things dramatically change. So what should have happened to Elon Musk's car is it should have absolutely blown all 4 tires out long before, probably when the rocket hit, somewhere between 100 and 150,000 feet would be my guess, probably even less than that. Those tires should have absolutely just exploded, straight up exploded.
We're NASA.
What about the breathing, the panting, the moaning, the screaming?
Fake, 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 fake.
Hey guys, how's it going? So my question for NASA is, how are you ensuring the safety of our astronauts in a vacuum? I want to make sure our astronauts have the proper training to survive the deadly vacuum of space. Proper training means you train in an environment that most closely resembles the harsh environment you'll be exposed to. Now there are 2 issues that I have with NASA's training practices. Number 1 involves the fact that NASA trains astronauts in a swimming pool when in actuality they are supposedly going to be working in the exact opposite environment of outer space. And my second issue with NASA is its ability to even create a vacuum here on Earth that is sufficiently similar to the alleged vacuum of outer space. So before we begin, let's see how NASA creates a vacuum here on Earth.
Spaceball 1 has now become Mega Made. Good! Remarkable. Now, commence Operation Vacuum Suck.
So this here is the Great Space Power Facility at NASA's Plum Brook Station in Sandusky, Ohio, which they built with our money. This is the world's largest and most powerful and expensive vacuum. Some of the test programs that have been performed at the facility include high-energy experiments, full-scale rocket fairing separation tests, Mars lander system tests, deployable solar sail test, and International Space Station hardware tests. I mean, construction costs were astronomical. So is the upkeep and maintenance. And obviously there's no astronaut training going on in there. And a little later I will show you exactly what they do with it. They use it for propaganda videos and drop a feather and a bowling ball. Ugh. Anyways, so first off, this chamber makes a high vacuum. That's all it can do. And this high vacuum is 3 levels before the vacuum of outer space. So it's not even as powerful as the vacuum of space in which they will be working. And for those of you who don't think a vacuum is powerful, and that the pressure difference between a vacuum and the atmosphere in which we live is not powerful, check out what a vacuum can lift, and then think about what it would do to a puny tin can in space, or a wimpy spacesuit, especially over time, or if there's any minuscule imperfection or leak. So check this out.
We're loading 42-inch 480 wall steel pipe, 3 to a truck. Pipe are about 40 feet in length, and they weigh about 9,000 pounds. We're loading them with an AccuVac vacuum attachment on a 450 John Deere hoe. Pipe weigh about, I think I said the pipe weigh about 9,000 pounds a piece. This vacuum attachment will pick, this one I think will pick 30,000 pounds. That's 15 tons just on a vacuum.
Now that's power. And it is funny how the vacuum chamber, like a submarine, has massively thick walls to withstand the difference in pressure. This is because, in the case of a submarine, the submarine must survive the difference in pressure that exists between the ocean, deep in the ocean, and the ground level atmosphere inside the submarine. Without very thick and structurally sound walls, the pressure difference would crush the sub. Likewise, the ISS and the spacewalking astronauts must survive the opposite but equally harsh difference in pressure that exists between the vacuum of space and the normal atmosphere inside their suit or inside the space station. So again, it's funny that they need extremely thick and structurally solid walls for a submarine and a vacuum chamber, but for some reason, in the more powerful vacuum of outer space, you can survive in a flimsy spacesuit or the tin can known as the ISS. Sounds legit. To illustrate this even further, on the vacuum scale, this monstrosity of NASA, our great space power facility, is only a high vacuum. You can see from the chart that outer space is 3 levels of vacuum beyond NASA's most powerful vacuum, which they don't even train in anyways. And all of NASA's other vacuum chambers are only medium vacuums. So right there, that's a fail. They can't even recreate the vacuum of outer space, and they don't train in a vacuum. There's almost no footage at all of any astronauts even in a vacuum chamber, and plus, they even tell you it's their policy to only train underwater. They don't train in a vacuum chamber. This is a complete fail. I'll come back to this point in a minute, but before that, I want to discuss the major problems I have with NASA's policy of training astronauts in a gigantic swimming pool. And really, the only alleged benefit of training underwater in a pool, they say, is that it simulates zero gravity. Well, actually, it doesn't even simulate zero G. It only simulates zero G on camera, in a video, making videos, but not in practice. To summarize why training underwater is a complete fail, I made a list of 8 problems with training underwater as opposed to training with something like a zero-G wire system in a warehouse. So here we go. Number 1, pressure underwater is the complete opposite of the vacuum of space. Underwater, the pressure is extremely high and will compress, it'll crush you with extreme force. In a vacuum, pressure is extremely low, there's no pressure, and you will explode. Your spacecraft will explode with the extreme force, and it will do so outward, the opposite direction of underwater. So why in the world would you train under conditions that are opposite those in which you will be working? This makes no sense at all. Total fail. Number 2, resistance in movement. Underwater, moving around and pushing off of things will be much slower and tedious as opposed to the vacuum of space. At least if training is done in a warehouse on wires, there will be less resistance, which is at least closer to the complete lack of resistance in space. Water is the exact opposite of a vacuum. There's a great deal of resistance when you move around underwater. Number 3, it makes no sense to construct a full-scale model of the ISS underwater. An ISS replica could easily be constructed in a large warehouse or a hangar. It would be much easier to build, maintain, modify, etc. This is just silly to do it underwater. Number 4, teams of safety divers and camera crews must also risk their lives underwater for astronaut training, with the unnecessary burdens of tanks, gear, tools, parts, cameras, production equipment, etc. Instructors could be more helpful in a normal environment with astronauts on wires in a warehouse. It would also be easier for the camera crews to fake it. Number 5, it costs millions to maintain the gigantic swimming pool. The underwater ISS model, the crews, equipment, it would be a fraction of the cost to use a warehouse with wires and a normal ISS replica. Common sense. Number 6, the performance and integrity of a spacesuit underwater is going to be the opposite of how it would perform and hold up in a vacuum. Training on wires at normal atmospheric pressure would at least be closer to movement in a vacuum than underwater, and how a spacesuit would react. A real vacuum chamber testing would be the best, but again, training underwater makes no sense. Number 7, weight distribution, inertia, movement, and reactions would be completely different underwater. Training to move and work with zero-G wire systems in a normal atmosphere would be closer to the alleged vacuum of space. Number 8, spacesuits, gear, tools, equipment, spare parts, etc. are all designed for use in space, in a vacuum, not underwater. Tools such as drills, wrenches, hammers, bolts, quick releases, they would all behave completely differently underwater. This makes no sense to train to use these underwater.
I'm astonished by how difficult it is to actually move around. The idea, like from the movie Gravity, that you could like reach out and grab something with one of these gloves? No way. Not gonna happen.
So, there are no benefits to training underwater, in my opinion. But there are many disadvantages and outright dangerous issues if you train underwater. The better option would be to train on the ground in a warehouse with wires just like they do in the movies. They can simulate zero-G just fine with puppeteers and wire systems. They can do this in a normal atmosphere with less resistance than underwater, So at least it's a little closer to moving around in space and operating and fixing things in space, if it was reality. So anyways, I mean, we know why they train in a pool. It's for the simple reason that on camera, floating around in a pool has the appearance of floating in space. That's it. Otherwise, it makes no sense whatsoever to train underwater. In fact, it's just silly and foolish. But we don't use our brains and ask questions about what they do with our hard-earned money. We just see it on the news and we believe it. Now, here is one of the few instances of an astronaut supposedly in a vacuum chamber. This could be made for TV drama from the 60s, but I think it's probably real. I think that they tried to use a spacesuit in a vacuum chamber, but quickly realized that it's impossible, at least in a high vacuum. So they immediately started their policy of only using swimming pools to train, and completely ignoring and remaining silent on the absence of vacuum chamber training of astronauts. And check out the caption. It says, "The video above shows the moments when Jim LeBlanc was subjected to a space-like vacuum, space-like, it's a medium vacuum, in a NASA testing chamber in 1965. Interestingly, although an accident, it's one of the only experiments into how a human would cope in such conditions, and thus our modern knowledge of the effects rely upon this incident." We're relying upon this one time they tried to put somebody in a vacuum chamber? Whew, it's pretty pathetic.
As I stumbled backwards, I could feel the saliva on my tongue starting to bubble just before I went unconscious. And that's kind of the last thing I remember.
Wow, that's pretty crazy. And originally I had a clip of the BBC video with Brian Cox where they dropped a feather and a bowling ball in a pathetic attempt to prove gravity, and I had to take it out because that was the first thing that got this video blocked. And I'll put the link in the description, but it's a horrible spectacle showing how they waste massive amounts of our tax money as they prepare the gigantic space power facility and operate it just to film the propaganda feather and bowling ball drop. And they all react like it's the greatest thing they've ever seen, and I don't know about anyone else, but I'm sick and tired of working my butt off so these jokers can waste my money on ridiculous productions like this. I mean, this facility is enormous, and even just sitting there unused, it takes massive amounts of money to maintain. And even more so when all of the workers have to show up and operate it for the propaganda. Heck, every time you shut the giant door, it probably costs thousands of dollars. And again, we pay them to create propaganda for us. Not the best use of capital, in my opinion. And then the next clip is the one that just got this video removed, and this was the clip from Smarter Every Day. I guess he didn't like how ridiculous he and astronaut Donald Pettit looked when they discussed the shutters on the cupola of the International Space Station. They basically talk about the tiny little O-rings that are used to create a seal for the 7 handles that open and close the shutters. They operate the handles from inside the cupola, and these handles close the shutters on the outside of the space station. So for me, the worst part was how ignorant Donald Pettit was when asked what to do in the event of a leak in the seal. He's like, then you have a leak. Probably seal off the cupola. There's probably a plan. I don't know off the top of my head, but there's probably a plan to replace the mechanism. It might require a spacewalk, all nonchalantly. And it's like, what in the world is he thinking? This is horrible. If the ISS were real, there would be a procedure for every possible contingency.
What's going on? Sanders, what's going on? It's Megamaid. She's gone from suck to blow.
On submarines, you train and practice emergency drills all the time. Even the lowest ranking member on a sub will know what to do in the event of an emergency. This is Donald Pettit, an elite astronaut. The astronauts are supposed to be the best and brightest, having to beat out hundreds of qualified people to become a NASA astronaut. I mean, are you kidding me? Where are the drills? What are the procedures? They would have a specific procedure for every type of incident. Loss of pressure, leaking seals, micrometeorite penetration, ammonia leak, I mean, come on, this is horrible. Where are the drills? The first thing they would show in videos would be them rehearsing drills. But instead, we get videos of spinning stuffed animals and making tacos, washing hair, blowing bubbles in space. I mean, really? Does anyone believe this stuff? If it were real, there would be non-stop, serious drills about how to stay alive in the event of an emergency. Then at the end, Mr. Smarter Every Day even exclaims, "You have the vacuum of space being held back by 2 little bitty O-rings. That's incredible." Well, he's right there. It is incredible that people believe it. And shame on us for being ignorant for all of these years. But anyways, at least we know now, and we can observe these things in greater detail with objectivity. So thanks so much for watching, guys, and I hope you all have a nice day. Adios.
Jerry DeMaz, hopefully I got that right, aka the Globe Vandal on YouTube, who worked as a maintenance repair technician for several years in a semiconductor manufacturing plant, maintaining and repairing ultra-high vacuum systems. And there's a reason I brought him on, and the reason is because, in Flat Earth, we talk about vacuum, the Earth and space, supposedly the infinite vacuum of space, a lot. And so I wanted to get his opinion on vacuums in general. Thank you.
Thanks for giving me the opportunity to come on. I appreciate it.
My pleasure. So let's get right into it. I don't know if we can get. Let's get into the vacuum thing in a bit. How did you get into Flat Earth?
I got to kind of start a few years back. The first time I ever was even introduced to the idea, ironically, was the Kennedy Space Center in Florida. I was off on a trip back then. I was working for a car stereo manufacturer called Phoenix Gold. We manufactured car audio amplifiers and things like that. And we were at I know this is gonna suck, but I was at Daytona Beach spring break. And
I've never been to one of those, so it sounds fun.
Yeah. So anyway, on the day before it started, we decided to head on down and go over there. And NASA, well, not NASA, but Kennedy Space Center, we were in the auditorium, and they actually brought up the Flat Earth themselves, and saying, yeah, there's people out there that actually still believe in the Flat Earth, and they think we faked the moon landing, and I thought that was kind of odd that they would mention that. And this was back in like 01 or 02. Wow. So this was quite a while ago, but way before there was really anything going on. So I walked around, and at the time I was a fabricator. I was a new product development manager and a fabricator, where I would design these ultra high-end audio systems. I'd build demo vehicles, 6-figure demo vehicle stereo systems.
Sure.
And so anyway, I knew a little bit about fabricating. And I took one look at that mock-up lunar module, and I thought, holy hell, who designed and built this? It looked like a joke. I just was in awe looking at that. And then you go and look at the rocket, and it's really impressive. That was the booster rocket was a completely different story. It was like you had 2 different teams on those things. The rockets were phenomenal, massive, huge. But then when it got over to the lunar module, it's like, got to credit Jake Gibson for his homeless tweaker shelter, because that's what it looked like, man. Yep. Well, fast forward a couple of years, I went to work for another audio manufacturer, and this gentleman was actually a engineer for tube amplifiers. And he hands me a video and says, yeah, we didn't land on the moon. And I laughed at him. I said, are you kidding me? I just thought he was a nut job. Right. But the only reason why I gave any credence to it was because, he was extremely well educated. And, it wasn't your typical weirdo trying to, pass off some freaky conspiracy theory.
Right.
So I watched the video, and once again, this was probably 05, I want to say. So this was well before the movement ever hit.
Mm-hmm.
And I don't remember if it was the funny thing happened on the way to the moon video. It was so long ago. I can't remember what it was.
Okay.
I just simply remember that it debunked a whole bunch of stuff. Most of the points we already know about.
Right.
And so then I thought, well, yeah, well, I didn't put two and two together that, hey, maybe the Earth's flat, or maybe they were, doing that to give us a fake shot of the Earth.
Mm-hmm.
Well, and about 3 years ago, I started thumbing through the moon landing stuff and revisited it. And then that just led into Matt Powerland's video, and of course yours and Shazwar Booty's. And I started watching all that, and they had some really good, valid points. And I thought to myself, wow, there's actually something to this.
Yeah.
But I kept it to myself, and I just kept researching, because I wasn't about to go tell anyone and make myself look like an idiot.
Nope.
And lose any credibility I had.
Right.
And I wasn't going to go forth with it until I could have an intelligent conversation on the topic.
Yeah.
But it's like, when you first find Christ, when you become a Christian or something, you get all excited and you want to share the message, right?
Yeah.
And sometimes it's just too early, but the passion there was definitely there, but I just didn't want to come across wrong. So that's kind of how I got into it.
Oh,
and
cool.
then I just kept going from there. And then I eventually, when I felt confident enough, decided to make a couple of videos. I have a full-time job, so I don't have a lot of time to make the videos I'd like to.
Yeah.
So I made a few short ones where I saw a lot of infighting going on I didn't like, and so I thought, hey, there's got to be a quicker way to get the message out there that's a little more light-hearted and can still state the facts, but in a humorous way. And so I came up with, you remember those Bud Light commercials, The Real Men of Genius?
Mm-hmm.
Those were always my favorite. I just loved them. And so I decided to do a spoof on those. So I started in on a series for those. And one of them was on the lunar module landing, and I did it to the music, and I imitated the voice and everything, and like the lunar module thing, not the lunar module, but the Curiosity rover on Mars.
Oh, okay.
And so what I did was I took all the pictures of like the walrus bones, the lichen, the lemming, the railroad ties, all the different evidences that were in NASA's photos, and I just turned it into a bit of a comedy. So go in there and check that out sometime.
Okay.
That's not what I'm on here for today. But anyway, there's my journey. That's how I got to here.
Awesome. Well, that's great. And yeah, I think the one you were mentioning was A Funny Thing Happened on the Way to the Moon by, geez, was that Bart Sabrell? Was he the first guy to help put that thing together over in the UK? And yeah, you're right. That if you believe in the moon missions, if you believe in the Apollo programs, you got to see that film, because it shoots. Now, does it absolutely prove a flat Earth? No. As a matter of fact, I half think it was one of their backup plans that let them fall back. So like even if you hated the Apollo program, you'd look at that little movie and say, well, yeah, but they faked it from Earth orbit, which means it's still a globe. Which was clever. That part I thought was clever, because you don't leak. That film doesn't get leaked out anywhere. That film is put under lock and key. Anyway,
yeah, that one really makes me wonder how that got quote unquote leaked.
Exactly. Talk to me about vacuums, because and you know the general. The reason why this is kind of important is that lots of people in the flat Earth community, and you heard this, have said that, where's the bleeding edge of space? Where does the edge of the atmosphere stop and the amazing power of the vacuum of space begin? And nobody can really define this. And what we're hoping that you can really do is clarify what the levels of vacuum are, what they're measured in, and the power of them. So, what do you got? What led you down this path when in your professional career? What resonated with you when it came to flat Earth and vacuums?
First of all, I started taking a critical look at the ISS and the lunar module both, and trying to see what systems they had in place for those, for the vacuum environment. And as I've been inspecting things, I mean, like the most popular one is definitely that floppy door on the ISS.
Yeah.
I can't help but I gotta believe there's gotta be a stronger. I keep wanting to believe there's a stronger door on that. I mean, that's just absolutely ludicrous. I mean, in the vacuum world, you get laughed out if you walked into the fab with something to seal a chamber up with that. That's just.
I mean, I'm sure it's a secondary door too.
Yeah,
you know,
yeah.
but the point is, why is it there at all?
There's no need for it.
No.
Because there's no window on the door.
No, so
what's the point of it?
Right. If you have a primary hatch, why do you need that thing? It's I can't understand. It's like a door cozy. That's really all it is.
I know. Exactly. I just kind of want to get into so people understand what vacuum is. And to give you a bearing, to give the people a bearing of just how radically strong the vacuum in space is supposed to be. Like, I'm more familiar with Tor because that's what we worked with. And just to give you a little bit more background about me, I was the guy that actually repaired the valves and maintained the valves and the vacuum chambers and worked through the computer systems that controlled them. So I have a pretty clear understanding of how vacuum works. But the atmosphere that you and I stand in is 760 torr.
Okay.
Have you ever taken a vacuum and just put it on your arm and flip the thing on and watch what happens to your skin?
Yes, I have.
Okay. I think we've all done that, right?
I think we've all done that, yeah.
Well, that measures at about 600 torr.
Okay.
So the smaller the number, the higher the vacuum, okay?
Okay, so smaller is better, and torr is at T-O-R-R?
T-O-R-R.
Okay. Power of a vacuum is measured in torr, probably named after somebody named Tor.
Yes, it is, actually.
Perfect.
And,
all right.
And we've all seen these tests. I'm assuming a great many of us have seen the test on YouTube where people throw marshmallow in a little, glass chamber and they'll vacuum it out. Well, these little pumps, they're just a rough, low vacuum pump. These are nothing even remotely near what the vacuum of space is supposed to be. So you've got basically 5 different categories of vacuum, and one of them's rough or low vacuum, and that goes down to 1 torr. And then you've got a medium vacuum, which goes from 1 torr to 10 to the minus 3 torr. And so people go, oh, I'm in a perfect vacuum. And it's like, no. In reality, perfect vacuum's not possible, because it all has to do with the relative amount of atoms within that given space that determines the level of vacuum.
Okay.
So then you have high vacuum, which is 10 to the negative 3 torr to 10 to the negative 7 torr. And then there's ultra high vacuum, which is where I was in, 10 to the negative 7 torr to 10 to the negative 11 torr.
Wow.
Okay. And then there's an extreme high, which is negative 11 on down.
Okay.
So, now, you want to guess what the vacuum is purported to be at the space station?
At the ISS?
Yes.
I would imagine to be in the negative range.
Yes.
So, -5?
-7.
-7. Oh, I wasn't too far off. Okay.
So ultra high. Yeah, it's in the negative high.
Okay.
Ironically, I did do some research today to see, and I actually found a NASA spec for their developing of their gaskets and their O-rings for their doors.
Right.
And they were only speccing to -8, which is interesting because when you engineer anything, you always over-engineer it. You always add an extra area of safety in there. Which I thought was kind of funny that they didn't do that. I mean,
So
you do that amplifiers or anything you build.
So the hatches on the ISS, which apparently they never close ever, for filming reasons, are only rated at -8 torr.
According to the document that I saw and that I read on the NASA.
All right.
So I'm just going to preface it with that.
Okay.
So, now I don't know if you remember, but back in about 1960, before the supposed moon landing, there was a gentleman named Jim LeBlanc, and he actually had a spacesuit failure in a vacuum-tested chamber.
Okay.
Very interesting results. We know everything boils much lower at much lower temperatures under vacuum.
Right.
Well, he had a small leak in his suit, and he fell backwards. He could feel the saliva on his tongue boiling, and then blacked out. And this happened like really quick. And this wasn't anywhere near the level of vacuum that they were in space.
Wow.
And they repressurized the chamber fairly fast, which surprises me because you usually would get bends, just like scuba divers, from repressurizing that fast.
Wow.
So, yeah, interesting stuff.
Huh.
Anyway, so now if you can imagine that if you were in space and you got a leak, you'd be in a hell of a lot of trouble. I mean,
instantly.
Instant. It wouldn't be no 45 seconds like they try and tell you. It would be instant. You'd be dead before you could bat your eye.
Because the vacuum would basically lower the boiling temperature of your bodily fluids to the point where you would be boiling. You'd be basically boiling at 98.6. And
yes, and the more vacuum you get, that there is a line that you can. There's a graph that you can plot that actually shows the boiling point just keep going down, clear down to freezing, to like 32 F.
Oof.
It's pretty crazy.
That is crazy.
So anyway, so now, like, I worked in the semiconductor industry. We did government contracts. We did gallium arsenide wafers, which are high-speed stuff that you can't get from like Intel because they're using silicone substrate, where we're using gallium arsenide, which allowed us to have our tolerances much tighter and do higher frequency stuff. So anyway, when we would pump down those chambers, an interesting thing I started to put together after being in the flat earth was we used three different pumps on a system.
Okay.
So you would first start out with a roughing pump that would get it down to about 1 torr, somewhere around there. And then we'd step over to like a turbo pump, which would then kick on. And that would get it down to like, you could get it down to like -7 torr on that.
Okay.
And then you would have to swap over to what they call a cryo pump. And there are turbo pumps that will pump down deeper, but they get exponentially larger and heavier and just ridiculous. So then you actually have to switch over to a cryo pump or a cryogenic pump, which basically is a frozen carbon filter. And what happens is that the remaining particles in that chamber bounce around and they get lodged into that carbon filter and actually bring the vacuum to a lower point. The reason they have to do that, Mark, is because the mechanical methods are no longer any good.
There isn't enough horsepower in the world to suck out what you need out of that.
No, not at all. So they have to go to that. And basically, that's what they call a viscous flow when it's down at the lower levels of roughing pump.
Okay.
And then there's a Knudsen flow, and then it gets to the molecular flow. And so those are the reasons for the different stages of pumping. And interestingly enough, like if you were to accidentally open one valve when it wasn't time, like let's say for instance the turbo pump, they weighed anywhere from 800 to 900 pounds for one turbo pump. And this is, now mind you, this is for like a 2-3 cubic foot max internal air volume that you were trying to vacuum.
Right.
And these things would spin super high revolutions, And if you accidentally opened that up too early while that thing was spinning,
Yeah.
it would rip it to shreds. You would hear the loudest bang you ever heard. It's just insane, right?
Wow.
So, anyway, with these pumps, the reason why I'm going into this is because you see them, like, for instance, they're trying to tell us they use parachutes to land the Curiosity rover on Mars.
Mm-hmm.
Well, you're in a vacuum. How the heck's it slowing that thing down with a parachute? It's not possible. How are they pushing off against anything with blasters or jets or anything? There's no atmosphere there to push off of. Period.
Sure.
End statement.
Right.
So, I mean, that right there is enough proof for me. But
I would agree. Well, let me ask you a quick question. If one, you're stating that it is extremely hard. We cannot even create an absolute vacuum down here on the ground, no matter what technology we're using.
No.
One. And two, it just all of a sudden occurred to me that because we're talking about submarines. They're in a pressurized environment, but it's the atmosphere trying to go the other way. But the thing is, that's a very, very, very heavy steel environment there. Whereas you're talking about the space station, which is super light, very flexible metal. So how is that counteracting the massive power of the vacuum outside of it?
Yeah, because it's basically the same situation as deep sea, only in the inverse. The pressure is going to push it outwards instead of the atmosphere pushing it inward. The inside's pushing it outward. So it's the same. It's just the inverse scenario. Wow. So it's every bit as strong.
Wow. And the
other people jumping out of those and going around in their pressurized suit. You know what I'm saying?
Oh yeah.
They're keeping their butt inside that vessel. And another thing that I noticed as I'm looking, I tried to spend a bit of time today and look around at the space station. And I saw so many holes today, I was just flabbergasted. In an airplane, they have, I don't know a lot about airplanes, but I know they have redundant systems.
Yeah, of course.
Now, how much more would you need a redundant system in space than you would in an airplane?
Oh, yeah. You need them. And we're talking military. The military always builds in massive redundant systems.
Yeah.
When it comes to that.
It's exponentially more important.
Also, which I thought was interesting, and we talked about this when the industrial valve expert called in 2 years ago now. Hard to believe, time flies. Where he was saying that, look, when it comes to the tolerances, when you're building the hatches, when you're speccing out the hatches on those ISS, you need a machine shop on board. He goes, every Navy ship has a full-blown machine shop on board so that they can make just about any part they need. And he goes, here's the thing. Machine shops use a ton of power. They're extremely smoky. They generate all sorts of waste. And the other thing is, he goes, they're really, really heavy. The machines you're using in a machine shop are tons and tons of solid metal. And he goes, where is this? Where is this thing on the ISS? How are they getting the parts? How are they getting everything? Because you were talking to me the other day and saying that the tolerances are extremely fine, and it's no joke. You can't just mail it up there. You just can't wrap it in brown paper and shoot it up to that thing if it's there.
Right. And if you look at the way they claim they're generating their oxygen, is basically they're using electrolysis in water. Okay, now let's think about this. They've got to store the water for this, first of all. Second of all, if you don't use a salt, or a potassium base to that water, it's going to take a lot longer to generate that oxygen. Number one. Number two, where are they storing all that water when they say they're so shy on water up there to begin with, so much that they got to recycle their toilet pee and drink that?
Right.
Okay. Right. And then the process basically separates the hydrogen from the oxygen. And they say that they're releasing the hydrogen into space and pressurizing the oxygen into a container. That's as per NASA.
You think they'd want to show off that system?
No. Yeah, and you know where it is? This is the funny part. It's like right by the cupola, which we'll get into in a minute. Mm-hmm. And it's a small section. It reminds me of the Wizard of Oz, right? It's like, we'll just make a door and we'll write Oxygen Supply Center. You know, that's basically what they did. You can't see what's inside there. It's basically a black box.
Right.
You can't see what's behind there. And it's only like, from what I can gather, maybe 5 foot by 5 foot, being generous. You know, as far as what I can see, who knows how deep it goes, but it's not that big. And so how are they generating enough oxygen for everyone to breathe based off that little space? And then also, every time they open that space hatch, the way they're decompressing it, according to what my research has shown me, is they're throwing it through a vent with a muffler on it to silence the sound.
Right.
And they're outgassing it out into space. So now you've lost all that oxygen that was in there, right?
Right.
And you've got this system that's only generating oxygen, not nitrogen, because we know in the atmosphere we've got 78% nitrogen, and we're 21% oxygen, with like the rest being argon and carbon. You're like at 0.9% argon and 0.03 on carbon. Mm-hmm. So where are they getting this nitrogen? So that would facilitate or create the necessity to have a nitrogen tank in there, because they must have nitrogen in there, because they also, before their spacewalk, are said to breathe only pure oxygen in that chamber. So if you're following their whole narrative, that means there's got to be nitrogen in there somewhere being supplied. But on that whole video, I don't see any room for tanks.
Right. Right, yeah, and you're absolutely right. And the average person doesn't realize that we're breathing, we'll just round it up to 80, 4 parts nitrogen and 1 part oxygen. So where the heck are you getting the nitrogen from? Because if you're breaking down water, you're only getting hydrogen and oxygen. So and honestly, and a pure oxygen environment, as you know, is really tricky, because one, it's very, very flammable.
Actually, it's not. In and of itself, it's not flammable.
Okay.
Hydrogen is, but oxygen itself will not ignite.
It won't ignite. But if you have a flame, but you don't want to. I'm sorry. Go ahead.
Oh, I was saying it'll oxidize things and help them to burn much more rapidly.
Exactly. Yeah. You know, I'm not saying it's like hydrogen where it's explosive. Where you can just touch a match to it. But the pure oxygen environment is no joke either. It's but you got a great point. Where the heck is the nitrogen coming from? In fact, I don't even know, until you had mentioned it, I don't even know how you make nitrogen if you had to synthesize it.
I haven't had time to look that one up yet.
That's a good one. Somebody look that up. How in the heck would you add nitrogen? Because you'd want to do that.
I know they'd have supply tanks of it, but I just don't know how it's made.
That's really interesting.
So now, let me tell you about this other thing, the valves, right? I'm just going to cap on those because I used to rebuild them.
Okay.
And I'm here to tell you there's no valve that's going to last a year without being repaired. And there's got to be a whole lot of valves in that place. I mean, a lot. But I don't see one single visible valve in there. Not one. I don't see it on the inside, and I don't see it on the outside.
Right. So where are they?
Where are they? And, I listened to the other vacuum show because I didn't want to hit the exact same points.
Oh, no, that's fine. That's fine.
So you've got pneumatic, right? You've got hydraulic, but you've also got the linear actuator, the motorized electric motor version, and then they also have a manual one that you can physically move as well. So definitely it's either going to be a nano electric type actuator or a manual one. But either way, you're going to want redundancy in that, because if that valve takes a dump, you're screwed.
Yeah.
You are screwed.
Yeah, you never see anyone even trying to repair or maintain these valves, ever.
Oh, not at once. And you have to replace the seals on them. You got to, you'll have to reabrase them sometimes. And there's usually like a U channel that the seal goes in, and then or the O-ring that it would go in, and then that meshes up. Well, there's sliding mechanisms and bolts and screws, and those bolts and screws do strip out. They do strip out, and they need to be repaired. The seals need to be repaired. You got to have grease there. I don't see tool sets anywhere around there to service that either. So I don't see the valves. I don't see the tool sets. I don't see O-rings. They never show you any of that. And then the way they explain most of their technology on the ISS is always, they just say, oh, here's, like, for instance, the oxygen thing. Oh, we just use electrolysis, blah, 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 and here's how you get the oxygen, and we outgas the thing. But they don't go into any more detail beyond that.
No.
It's just more, hey, trust us, it works, we're NASA.
It's just a machine that's behind the door.
Exactly.
With the sticker on it. That's it. Oh my Lord! Oh my God! So let me ask you this, and I know you got other things I want to cover. I want to ask you this before the break because I want this statement from you. In your opinion, is there any way, in your professional opinion, is there any way that the ISS can function as advertised by NASA?
No way.
No way. There's nothing even remotely true about anything they're saying up there.
Well, I mean, there's systems that would definitely work. But wait till we get into the cupola.
Okay. All right, so go on. We got 3 minutes, actually 2.5 minutes before the break.
I can cover the cupola in that time.
Okay. What do you got?
Okay, there's 7 windows in the cupola. I think most of us have probably seen the video of the shutters, which I think looks highly suspect the way they move. It's supposed to be mechanical, and she's turning it really slow, and it's moving on its own whether she turns it or not, so it's not like a very linear system in its movement with turning the handle. But anyway, they went back and researched the guy that actually designed it, who now owns a shop that builds something completely different. But he said basically the only thing that seals off all 7 windows, all 7 turnkeys that open and close that, which is directly connected to the outside at a -8 torr, is 2 tiny little O-rings. Now, mind you, you've got to be able to service this thing, and it's been up there for, what, almost 20 years?
Yeah, 20 years. And
these are moving part O-rings. These things would need to be replaced all the time. I could throw out a number, but it would be a guesstimate, but probably every 2 to 3 weeks if you're opening and closing it a lot.
2 to 3 weeks?
Depending on how much they opened and closed it.
Wow.
And that's even considering those tiny little O-rings would hold up to that high a vacuum, which I'm telling you, there's no way you're going to have an O-ring that is dynamic that's going to hold at that vacuum. You have to compress that O-ring pretty solid to keep it from losing vacuum.
Wow. Incredible.
Or losing pressure in the cupola. There's no way. No way. And then there's 7 windows, and you're telling me that out of 14 O-rings, none of them have ever failed in 20 years.
Right. Yeah. Good. Excellent. We're on with subject matter expert Jerry from Utah. We're talking about industrial vacuums, and we left off with the ISS being a physical impossibility because all the things they advertise up there, there's way too many moving parts, way too many high-pressure systems for this thing to be a reality. Yes, you believe that is true, right? The ISS is a piece of junk. There's no way it can do what they say it can do.
No.
Cool. Where do you want to go from here?
Like when I was at the fab and I was doing maintenance repair work, we had a team literally 24/7. We never closed down. And we all had our own tool sets that we were assigned to. And it was because those things are very tempered. They're very, what do you want to call it? They're finicky, yeah. They're very finicky. Yeah. And so you've got to be ready to fix those things quick, especially up there if something's going to go wrong. And
yeah.
so
Well,
it's not
I mean,
pretend-
if you like, for example, let's say you were hired to go up there, like Bruce Willis in Armageddon, and to be a machine shop guy up there, right? I can't even imagine what you would have to bring with you, just so you'd feel somewhat competent to do what you needed to be done. Yeah.
Yeah. And the funny part is it's like they just keep inventing stuff to do things, right? Oh, you got to go to the bathroom. Oh, well, we got a thing that turns the stuff into this and that. And it's just a brush over how it does it. They never get into the real science of how it works most of the time. But you start, I started looking at those solar panels today. I'm like, okay, how big are they? And then I started, well, how much does it take just to power one pump? And then I'm thinking, okay, you got the pump, you got the electrolysis, you got the lights, you got the, you got the oxygen. There's so many things to power up.
Right.
I just can't even fathom the load on the electricity.
Oh my God. And the daily maintenance. You know what always bothered me, and it's bothered several people that have looked at the ISS. When do you see an astronaut with a frickin' wrench, or any tool for that matter? They should be working. There should be dedicated guys up there working on things, like you said, all the time. There should be a maintenance sheet. In fact, any Navy guy will tell you this. On a Navy ship, you're always working on stuff. Always, always, always. And yet, the only thing you see is these guys floating around in their khakis and their polo shirts and their socks. Yeah. Not a care in the world. You know, it drives me insane. Not to mention the little thing, like somebody mentioned, it's like, look, you get a micrometeor, again, if you believe in space, the size of a nickel that punches into that, you're doomed. You could say you can say what you want about patching something, but if it's negative, whatever, let's say it's -9 torr outside that space station, that's it. It is over.
Oh, right? Yeah. And then the job I'm doing right now, ironically, I'm actually, we're working on some, I can't disclose what, but we're working on something for solar panels, and we actually test those solar panels. And let me tell you, those things are fragile. I mean, really fragile.
So even the tiniest space rock, and they're.
Oh, yeah. If you dropped your cell phone on them, they'd break.
Wow,
but
that is
I'm sure they put a some kind of a coating, or not coating.
Oh, sure.
But still, they're very sensitive. Any banging around, those things would be history.
Yeah. You know, we don't even have. Let's pick on ISS a little bit more. I'm going to pretend I'm Jaron tonight, because Jaron loves tearing apart NASA, and that is, we don't even have a rough cut time lapse of the assembly of the space station.
No, and can you? Okay, let's go into SEALs again.
Yeah.
Okay, on that level, you have to be so absurdly clean when you're sealing up that high of a vacuum level. It's not even funny. Yeah. Just to give you an idea, if you have your stupid fingerprint left inside like a chamber, it'll come as what they call a virtual leak, because the outgassing from the oils on that print introduces more atoms into that chamber, and you will see it not be able to pump down, all because of a stupid little fingerprint.
Wow.
It's insane. But if you have like a little tiny hair or a little tiny speck of dust on the O-ring, and you think it's clean, we've wiped it down with IPA, isopropanol, and we put it in there with the vacuum grease and sealed it up, and then you go to pump it down, and then all of a sudden you're like, it's not pumping down. You take it back apart, and this is in a clean room. You've got the full bunny suit on, gloves, hairnet, glasses, mouth guard, the whole nine, and you still can't be clean enough. It's insane. And sometimes you have to, and you've got to replace those O-rings constantly. We have a healthy supply of those O-rings around because they constantly need to be changed.
Yeah. Yeah, I know, and the industrial valve guy that I talked to 2 years ago said in his statement the same thing, which was there's so much maintenance, and the tolerances, when you're the O-rings and when you're fitting the doors, the tolerances are so extreme that there is no margin for error ever, to where you're constantly machining new parts, constantly adjusting seals, and we never ever see that ever. Well, heck, let's go the opposite direction. We never even see him close a freaking hatch.
Oh, no.
In the military submarines, and we've all seen it in the movies and documentaries, you walk through one section, you close the door behind you, and you go to the next section, because if there's a leak, you don't want the whole submarine to go down. The ISS apparently is the opposite of that.
Yeah.
Where they need, but I get it, because if you're going to do filming and you want to make sure there's as much uninterrupted footage as possible, you need these guys floating through multiple sections, and that gives the illusion that everything's great and everything's cool, and we can just ship things up there instead of shipping O-ring parts, because every piece would be so meticulous and every piece would be padded so much and weigh so much, and yet they're being sent guitars, flutes, gorilla suits, every NFL jersey apparently from every team, because it was done before the playoffs even started. It's just mind blowing. Okay, anyway, what else you want to throw in there before eventually? I'm hoping we can take a few calls tonight. What else?
Yeah.
What else you got for me? Anything fun?
Let's see. I got to bag a little bit. I don't like bagging, but some people are just too easy.
What do you want to go after?
That Don Petit.
Okay.
What is his marketing? It's like he sounds like he's talking to kindergartners every time he talks.
Right.
It's like we're slow class or something.
Right. The man that said we lost the technology to go back to the moon.
Exactly.
Yeah.
He just drives me nuts listening to.
I'm honestly embarrassed every time he gets on. It's like, that's the guy, that's your press secretary, that's who you want out in front of the cameras, because the way he's explaining it is not very. I mean, I know he seems sort of convinced. He's just reading what they told him to, and it's like I have no doubt he believes it, but it sounds so hollow from him.
Right.
It's like, oh yeah, we just don't have the. He kind of who he sounds like? He sounds like Marty McFly's dad in Back to the Future in the first one. That's, if you put Marty McFly's dad, McFly, you put him in front of the camera, that's what he kind of sounds like.
He'd probably be better than.
He'd probably be better.
Yeah.
Oh my God, it's horrible. Who else do you want to go after? Anybody?
I want to talk a little bit more about the O-rings.
Okay.
Because there are many different kinds, and they manufacture them according to what you need. There's a permeability rating on them that will change according to the temperature that they're placed in, and the pressure that they're actually compressed will change as well. And basically, you've got like a nitrile, a Viton, a EPDM, silicone, neoprene, hydrogenated. And then there's a PTFE. And the one that has the greatest range, like from hot to cold, is good from negative 300 Fahrenheit to 500 degrees Fahrenheit. So
that's quite a range.
That's a really, none of the other ones are even remotely close. That's definitely the best one out of the lot for that type of O-ring.
Yeah.
But still, that's well under the range that we're supposed to be in the thermosphere.
Good point.
And then so most people are familiar with the standard, nitrile or rubberish silicone or neoprene O-rings, right?
Right.
Well, they actually have, when you get into ultra, like extreme high vacuum, you want to guess what the vacuum on the moon is?
Negative. Are we talking about torr? Measurements in torr now? Negative 10.
Negative 11.
Close.
Yeah, good guess. So anyway, they go into a different, when you get into that high, those other types start to become no good. Because the permeability of them.
Right.
They just won't handle it. So what they actually have to do is go to soft metals.
Right.
So they'll use like a copper ring.
Yeah.
And the way it works, and they also use silver. interestingly enough, the copper melts at 1984 Fahrenheit.
Right.
Silver melts at 1763.
Okay.
So the thing about these type of O-rings or gaskets are they're a one-use time. You can't reuse.
That's it. One and done.
Yes, melt it down, make another one.
Oh, wow.
So the way they work is there's a channel and a knife. So the knife, you place the O-ring over that channel, and then the knife portion, which would be like on the lid, would press down into that, and that would create your seal. With the soft metals, it does better. But in order for those to work, the metal that it's connecting, like on the door and the base, those actually have to be highly polished. And that's how fine it has to be to contain that sort of a vacuum. I mean, it's insane.
That's amazing. That kind of reminds me of when you were saying you have to abandon one material for another. Most people know that your average Lamborghini, all the normal cars use rubber wheels, but when you get up to like rocket cars, like the cars that break the speed of sound, there is no rubber made that can handle those speeds because the centrifugal force just shreds them. Yeah, they have to switch to ceramic wheels. If you're wondering what those are, it's basically rock. You basically having wheels made out of rock and hope to God your shock absorbers handle it. And you're basically talking Flintstone wheels because that way at least you know that they're not going to tear apart at the high RPMs. So,
is a good way to think about the ISS because I mean the pressure in the ISS compared to the atmospheric pressure around it is like many times greater than what a tire is. But have you ever seen a tire blow?
Yep.
Insane.
Oh man, I just wanted to say I am loving this conversation because you're just hitting on those physical things that people cannot dispute. Oh my God, it's so frustrating because but you're presenting it in such a good way. I'm loving this. I'm loving it.
I'm glad. Go ahead.
Go ahead.
No,
I was just going to ask if you could talk a little bit more about the cupola stuff because I've always looked at that and wondered how in the hell does that stay sealed? With a crank that goes outside.
I got you. So it's like like a little hatch on a submarine, but yet it's in space. So how exactly does that work? Jerry, would you like to chime in at all? You want to reiterate anything?
Yeah. Basically, what happens is those O-rings, in theory, roll as it's turning. Well, anytime you move anything on something else, you've got friction. So first and foremost, it would need to be lubricated constantly. Second of all, that pressure on those O-rings would not be a loose connection. It would have to be fairly tight, probably extremely tight. When I would close up a chamber, for instance, we had one tool, you'd have to go down and you'd have a torque spec for that. And you would have to do it much like you do a car tire. You do the star pattern so that it all lays down evenly so that there's not an uneven surface. And so those things have to be adhered to or it's not going to seal up right. So to have something rolling at that high of a level is just ridiculous. There's no way in space that would work under that vacuum.
But it would work in an underwater training facility.
Exactly.
Yeah.
Correct. Yep. It works in the pool. It does work in the pool.
It would work if James Cameron was directing.
Yeah, that's awesome.
Yeah.
Michael Bay.
Yeah, if he was directing. Whoever's shooting this thing underwater.
Sorry.
I keep thinking when I keep watching the scenes of the ISS, because I know NASA steals from everybody steals from everybody else, but I keep thinking of the 1989 movie The Abyss, where James Cameron had to invent an underwater scene where he took these giant swimming pools, but they were outdoors so they could lower stuff in real easily. And they filled the top of the pool with layers and layers of tiny black rubber balls to where it blocked out all light. And when he did that, it was amazing because not only could you simulate underwater situations, but given the right lighting, you could also simulate space. Yeah.
I just want to throw one more thing out there if you could touch on the spacesuits themselves. Why don't these guys look like the Michelin Man when they're out there?
All right, Jerry.
I was actually going to touch that topic.
Can you do it in 2 minutes before the break? Can you start it in 2 minutes before the break?
Yeah, I think so.
Go, do it.
Yeah. From what I've seen, I don't know how you'd come up with a material that's stitched together, let alone just be a material that's not aluminum that would hold up to that kind of vacuum. I've never personally wanted to see how it would perform, but I don't see in my mind how that would work.
If the Tor is that high, the vacuum rate
it
is so
would totally be the Stay Puft Marshmallow. And and their argument is, we pressurized the suit. Okay, so you're making it that much even greater because you're putting more pressure in there. So theoretically, that extra pressure should be pushing out on it even further because it's putting more force in the outward direction.
Yep.
Right.
Yep,
Okay.
I totally believe it. Yeah, in fact,
awesome.
Wouldn't you have to treat it kind of like a deep diving suit where it's all metal, and very, very small sections of moving parts?
Yes. What was it, a gym diving suit, that big metal one with the
hooks,
rotating balls on it?
Everything is super heavy. Because, I think you're right. What stitched material out there, what soft material can counteract a vacuum? Can counteract a -9, -10 vacuum force? How is it?
And then you look at all the seal points, the points for error in seals. I mean, they've got like 4 cuff lengths of seals at different locations just in one arm alone. You got the gloves, you got the elbow, you got there's like a center cap that connects the arm and the shoulder together, and then the helmet. It's like and then they kind of brush over the pants section and the shoe, so you don't quite see what's going on. It's they put flap over things.
We're going to break right now. We'll be back in 3 minutes, guys.
They must be using space. They must be using space Velcro.
One subject I had not heard mentioned tonight was how does refrigeration, climate control relate to a vacuum? Wouldn't they effectively be just in the middle of a big thermos bottle in our infinite vacuum of space, alleged? And then, how do you transfer the heat? We've heard the story of, the astronauts, sublimating water out of the back of their backpacks, to create that differential. But I still haven't heard it from anybody, a vacuum expert. Let's talk, refrigeration, climate control.
What you got, Jerry? Yeah, I think.
I didn't have to do a lot of climate control with what I had. We had a bake-out process that we would actually use to help bring the chamber into vacuum because, say I would clean a thing or wipe a chamber down with IPA, that would still leave some moisture in there, and we would bake it out to help speed up the process because that would severely dampen the pump down time. Pump down time was huge in the semiconductor industry, but I didn't do. I don't want to touch into an area that I really didn't deal with.
Okay, that's right.
I wasn't in HVAC, where I was doing heating and cooling scenarios, so I can't speak a lot.
Sure, I just heard. Yeah. I heard a guy who called in on Mark's show. He had referred to himself as being a refrigeration technologist, and he was also questioning, where does heat go if it isn't truly a vacuum? And as kids, don't we get that? I'm old enough to remember the actual glass vacuum bottle you'd have, with that little glass piece. You could actually replace that if it broke. You go pull that out, put it back in, and your soup would be hot all day, or your whatever you had to keep cold all day. Wouldn't I've heard that, I don't know if this is accurate, but the human body puts out something the equivalent of a 100-watt bulb. Now you got a number of astronauts in there. It's just going to continue to heat up and heat up. And I remember, and this is, many years back, because NASA's been pulling this garbage for years, but there was something about the air conditioning had failed, of course, and the astronauts were getting all hot. And, and then at the same time, they're telling us about Apollo 13, they're freezing. Then you got the whole rotisserie thing where we spin we're spinning the capsule, keep it, it's like, it's a rotisserie. I spin my chicken, it cooks on all sides, so some of the stuff ends up, just the same ludicrous, transparent stuff that they spin to us. And I think they're just really counting on the fact that people are lazy. No one's they're just used to getting their news, oh, sure, this is what it is. Here's Mars, Pluto on, the picture of Pluto on Pluto, just gotten pretty ludicrous, as it were.
Right.
Well,
go ahead, Jay.
Oh, okay. I was going to say, we did I don't know if you heard that talk earlier, and I don't know which aspect you were questioning, but, as your vacuum does go down, boiling point's definitely lower in temperature. Sure. So yeah, but you got to realize that chamber is, maintaining atmospheric pressure. So, inside it wouldn't necessarily be affected. I think the only thing that would is if that sun's hitting, the way they say it hits, they should have some pretty serious heating and cooling problems if things work the way they say they do.
Right. And you got a big question here because go ahead, Chip.
Oh, I was going to ask a slightly unrelated question. He had mentioned guitar manufacturers of tube amplifiers, and I just wanted to know what the torr level over the average vacuum tube was.
That's a good.
I gotta look that one up. Okay, while you're looking up.
Well, I know what a TV is.
Oh, what's the TV tube?
The old cathode ray TVs were -7 torr.
Right. Oh. Okay. So got it. One other thing, Mark, I wanted to mention this, something you had mentioned a couple shows back, and you were talking about the metric system, and how in America, we were just holding on to the English system.
Yeah.
I want to make one point that the metric system, the meter was derived from the measurement of the so-called, ball Earth from the pole to the equator from a meridian that ran right through Paris, which is 1/10,000,000th of that distance. So the metric system is entirely ball Earth derived. Whereas if you look at the, say, English system, it was the cubit, it was the human body. The inch was the length of a digit in your fingers, or roughly so, and weights
and
and
the
measures
foot,
and so forth.
and
one appears more divinely, referred to, and the other one is clearly based entirely on the ball Earth. So that's more meat to chew on, if you will.
I have not heard anyone mention that. That's fantastic. That the metric system is based on the sphere measurement, and the other system, whatever you want to call it, is based on us. That's great.
Yeah. So I just that's another, like I said, more arrows into the fire, if you will.
Oh, that's good. Yeah.
All right,
me, I love arrows into the fire.
I will say this, that this vacuum thing has always sat with me because the idea of an infinite vacuum, and Mark mentioned the Michelin Man thing. Ralph Renee, God bless him, before he passed away, did a video in which he put a rubber glove, and he built his own vacuum chamber, and he put his hand in. He said it was like steel. He said he could absolutely not move that glove. So wouldn't a high vacuum like that make these things into essentially rigid structures, right?
Absolutely, yes. And that, you got to realize that wasn't even down to 1 torr. And you're not even in the ballpark of what the vacuum of space is. I mean, you have no comprehension how radical that vacuum is. I mean, you look at the chamber.
Oh, well, they're telling us if you talk about an infinite space, the vacuum would have to be near infinite, by definition. Any equation you function, you put infinity into is going to kind of level that equation right out off the bat, I would think.
I was thinking about something before I went to the conference, and it was about, because people were saying, are you launching this big war against science? I'm saying, no, I'm not. We all work with science every day, and there's some really great stuff that has come from science. What I don't like, and Robbie Davidson touched on this, was the idea of scientism, where science starts to make leaps of faith where they shouldn't. The biggest, of course, is that Neil deGrasse Tyson said that science is true whether you believe in it or not. And I thought that was one of the most arrogant things I've ever heard. And if Neil is ever listening to this, or any other scientist for that matter, let me throw out another name for you, which, in fact, you, Jerry, may know this name, and that is Kelvin.
Yep.
William Kelvin. I got to mention this guy because he sticks out like a sore thumb in the world of physics. And that is William Kelvin, who was raised in England, and he is the father of thermodynamics. Anyone that knows anything, you've wondered, it's like, where have I heard that name before? Absolute temperatures are measured in Kelvin. He was at the top of his game. He was knighted. He was absolutely, he blew Neil deGrasse Tyson out of the water in terms of accomplishments. Maybe not movie roles, but definitely accomplishments. Neil deGrasse Tyson can't hold a candle to him. Physicists use this guy's name in every university every single day. And yet, at the top of his career, when he was addressing all sorts of things like the Royal Society, he came out and said that heavier than air flight will never ever happen. He also said that balloons are the only thing you're ever going to get up there, and he has no faith, not one molecule of faith, and notice how he said that, in the Aeronautical Society. And this was not something that was done a long time ago. He did not say this in the 1600s or the 1700s. He said this in 1900. And a few years later, they started building airplanes. Now, did he know that the internal combustion engine was going to make huge leaps and they were going to figure out a way to make heavier than air flight? No, he did not. But the point was, he made the statement, and he had no right saying it, and he was 100% positively, absolutely wrong. So, when Neil deGrasse Tyson comes out and says that science is right, no matter what, has no credibility whatsoever. Anyway, that being said, Jerry, would you like to plug anything before we let you go? Because unfortunately, the show is coming to a close.
I'm getting ready to do a series. I decided after doing this show, I'm going to do a one, and I'm going to call it NASA Pass or Fail.
Nice. That's awesome.
All right.
That's awesome.
And basically, I'm going to treat them like they're my student. And we're going to run them through scientific tests and say pass or fail. We'll go over the seals and all different kinds of things.
That's great. I'm looking forward. Is that going to be on your Globe Vandal?
Yeah, Globe Vandal Demise. And check out the other two, because I've got like 4 or 5 videos on there, I think. But the good ones are the Real Men of Genius. They're pretty funny. They're just short, like 2-minute videos. They get the point across in a humorous way that, you know, that one way or another you'll enjoy it, even if you don't believe it. So
awesome! I'm looking forward to it. Sounds fun. And thank you for coming on, and thank you for reaching out. We're heading out of here. Say goodbye, Jerry.
Goodbye. Once again, take a look at my NASA's Mars Picture Taker Guide by the Globe Vandal. Thanks for having fun, and have a good night.
All right, I'll be here next week. Same flat time, same flat channel. See you, everybody. Stay on for a sec, Jerry.
What is this? Is that a model of the flat geocentric Earth?